Here you have a skydiver that is falling towards the earth at a constant speed for a long time after jumping from an airplane. So you have to first state his initial acceleration.
So, because it's constant speed.
Okay. On the diagram, draw and label all the vertical forces. That this thing, right? The initial, I believe, right? What the initial means, right, is when you first step out of the plane, which may be 10 meter per second square. It's more likely to be this. As I was saying earlier, the part one, right, there might be another interpretation of the question, which means he has not stepped out of the airplane and all that. So then the initial acceleration will be 10. Okay, part two, okay. Part three, part B. So state the time where the skydiver opened his parachute.
How to count the time like that? But there's 10 boxes until 15.
There's 10 boxes up to 15. You mean here? You mean from here to here? Where you want to count? So 10 boxes to 15, right? That means 10 boxes 5 units. One box is 0.5.
Well,
Which one? Which point do you want?
at the point just before it goes down.
This point?
Yeah.
So you know 10 boxes is 5. So one box is 0.5. So here is 4 boxes. So it's 2. So that means this point will be...
It's 12.
State the type of acceleration the skydiver undergoes from the time he receives the signal to the time he opens the parachute.
Acceleration.
Is here
What do they
the
mean by type of acceleration?
type of acceleration? So it means increasing acceleration, decreasing acceleration, zero acceleration, no acceleration, etc., etc.
Decreasing.
Read the question carefully.
Decreasing.
Undergoes from the time he receives his signal to the time he opens the parachute. So he opened the parachute here. So that means this part that they were talking about is actually here.
Constant acceleration.
Constant acceleration. Constant acceleration in a VT graph is like that. It's a straight line. This is constant acceleration. So VT, like that, this is zero acceleration. That's why just now I say the very first part of the question, right? The initial may not be the initial they're talking about over here in this graph, but is when before he stepped out of the plane, or he just stepped out of the plane and he hasn't started falling. Then you will realize that that answer must be 10, so that this answer can be zero acceleration, because on the graph, it shows you a horizontal line, which is this one. So this one has zero acceleration. You know what I mean?
Yeah.
Yeah. So it's the different point of the question itself. The initial is not the initial when he before he opened parachute, or he just dropped, but it's more like he hasn't fall yet. That's the initial. So this one, right, is zero acceleration. So then use your answer in part B to explain how the weight of the skydiver relate to air resistance. Cannot see. I shift a bit. Explain how the weight of the skydiver relates to the air resistance before he opens the parachute. So 2 marks again down here for this one.
I don't understand the question. What do they
So-
mean by weight relates to air resistance?
That means the relationship between the weight and the air resistance. Your question down here, right, your first part, your first part here, the previous part down here, you have zero acceleration. So then they say they use this, they tell you, you know, this is your acceleration. Then, and on top, you draw the guy with the air resistance and the weight, right? So, then, so based on your answer, zero acceleration, right, they want to know the relationship between the air resistance here and the weight of that skydiver before he opened the parachute. And you notice at zero acceleration means your Newton's second law, right? You have this. So they want to know, because F equals F net for F resultant is this, because zero acceleration. Then you want to know, they want you to tell them what is the relationship between the air resistance and the weight in this diagram. So the answer is actually on the diagram that I drew. Okay, so this is the relationship that they want. Okay, then you have to explain why is it like that. So explain this relationship.
The air resistance equals the weight of the skydiver.
Why? The air resistance is equal to the weight of skydiver. This is the relationship. Then you have to explain. So repeating whatever I wrote is not explaining. So if you want to explain, you will have to make use of this. You have to make use of this. Write something based on this. So you start from acceleration equals to 0. So what does it mean? Since the acceleration is 0 before he opens the parachute, then air resistance is 10. Why is air resistance 10? So since the acceleration is 0 before he opens the parachute, okay, and the resultant force is minus the weight or and F net is equals to 0, therefore the weight must be equals to the air resistance. Right? Yeah, air resistance is not 10. Where did the 10 come from? You mean the acceleration is 10? No, the resultant force is mass times acceleration, but you told me that in part 2 that acceleration is 0. So because acceleration is 0, if acceleration is 0, that means the resultant force F equals to ma will be 0. So then resultant force is also air resistance minus weight, or weight minus air resistance. Then weight and air resistance will be equal. Then that will give you the reason to why the air resistance is equal to the weight. Okay.
Means since the acceleration is 0, F net equals to 0, so weight must be equals to F resistance.
Okay, like that is enough.
Yeah.
Calculate the total distance traveled between 0 and 10. Let me write it out. Traveled between t equals to 0 and t equals to 10. Yes, 10. So distance equals to area under the graph. That one is correct. So how? The time traveled, the distance traveled between 0 and 10. 10 times 54. Describe the motion of the skydiver after he opens the parachute. So you already know that open parachute is this line. So they say describe the motion here.
Increasing acceleration.
Increasing acceleration.
Increasing acceleration.
Why increasing acceleration?
Increasing acceleration because it's going down.
Okay, again. This is increasing acceleration. Increasing acceleration is like this. Because the VT graph, the gradient continues to increase. That means acceleration equals to gradient. So increasing gradient equals to increased acceleration. So this is
decreasing acceleration.
Okay, this is increasing acceleration. So then you say decreasing acceleration. Right? So I will draw decreasing.
The gradient is going down.
The gradient is going down. Increasing acceleration means is
or decreasing.
This is gradient becomes shallower and shallower. So this is the decrease in gradient. That means decrease acceleration. So the graph that is this is decreasing acceleration will look
decreasing.
So decreasing there's this thing called decreasing deceleration. So you have another two graphs, one which is like this, and one I have no space, but I have to draw on the other side. That means it's like this.
Decreasing.
So this is gradient drop. Okay, and then acceleration. This is not acceleration, this is deceleration. Okay. So this is decreasing deceleration. Then this one is like this. So the gradient is negative, but it becomes more and more negative. So this one will be increasing deceleration. So over here, that means this is a decreasing deceleration. Okay. So first part down here, it is decreasing deceleration. Then there's a second part here. So you will have to say from 12 from 12 second to this part. This is what, 26, 27, blah, 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 blah. The is decreasing deceleration. Then after that, from 27 to 30, then travel at constant speed. Okay.